Vitamin E has drawn scientific interest for its possible role in cancer prevention, largely due to its ability to protect cells from oxidative stress and DNA damage. As a fat-soluble antioxidant, vitamin E integrates into cell membranes and helps neutralize free radicals, unstable molecules that can harm cellular components and lead to mutations. By shielding DNA from these potentially damaging effects, vitamin E contributes to cellular stability and may lower the likelihood of mutations that can lead to cancer. Although research findings have been mixed, and some caution is warranted when it comes to high-dose supplementation, the protective potential of vitamin E, especially when consumed through natural food sources, remains an intriguing and hopeful area of exploration in cancer prevention. The biological rationale for vitamin E's role in reducing cancer risk lies in its capacity to prevent oxidative damage, which is a well-established contributor to the development of many types of cancer. Free radicals are generated in the body as a result of normal metabolism, but their production increases significantly due to environmental exposures like pollution, cigarette smoke, radiation, and even chronic inflammation. If left unchecked, these free radicals can damage DNA, proteins, and cellular membranes, setting the stage for abnormal cell growth. Vitamin E helps interrupt this damaging cascade by neutralizing free radicals before they can cause harm. This antioxidative action may be particularly valuable in tissues that are frequently exposed to oxidative stress, such as the lungs, colon, prostate, and skin. Some observational studies have suggested a potential protective effect of vitamin E against certain cancers, including prostate, colorectal, and breast cancer. For example, research has indicated that people who consume higher amounts of vitamin E from food sources may have a lower risk of developing some of these cancers, likely due to the combination of vitamin E with other antioxidants and nutrients present in whole foods. The synergy of nutrients from almonds, spinach, sunflower seeds, avocados, and other vitamin E-rich foods may help reduce inflammation, enhance immune surveillance, and protect against cellular damage in a more balanced and natural way than isolated supplements. However, clinical trials using high-dose vitamin E supplements have yielded inconsistent and sometimes concerning results. Some large-scale studies, such as the SELECT Selenium and Vitamin E Cancer Prevention Trial, found that high-dose vitamin E supplementation did not reduce the risk of prostate cancer, and in fact, appeared to slightly increase it in certain populations. These findings underscore an important principle in nutrition: more is not always better. High doses of synthetic vitamin E may disrupt the natural balance of antioxidants in the body or interfere with other physiological processes, potentially leading to unintended consequences. This distinction between food-based and supplemental vitamin E is critical. When vitamin E is consumed as part of a balanced diet, it is absorbed in appropriate amounts and delivered alongside other beneficial compounds, such as fiber, phytochemicals, and healthy fats. In this context, it supports the body's own antioxidant defenses without overwhelming them. Supplements, especially in megadoses, can bypass these natural regulatory mechanisms and introduce a different biochemical profile that may not be entirely safe or beneficial over the long term, especially in individuals with pre-existing health conditions or a history of cancer. Beyond its antioxidant properties, vitamin E may also exert cancer-preventive effects through its role in immune function. By enhancing T-cell activity and supporting healthy inflammatory responses, it may improve the body's ability to detect and destroy abnormal cells before they develop into tumors. This immunomodulatory effect may be subtle but still meaningful over time, especially when combined with other lifestyle strategies such as regular exercise, a nutrient-rich diet, and avoidance of carcinogenic exposures. It is also worth noting that different forms of vitamin E, namely the tocopherols and tocotrienols, may have distinct effects on cancer biology. Emerging research on tocotrienols, which are less common in the Western diet but found in foods like palm oil and rice bran, suggests they may have more potent anti-cancer properties due to their ability to inhibit cancer cell growth and promote apoptosis, programmed cell death, in laboratory studies. While this area is still under investigation, it adds another layer of complexity and promise to vitamin E's potential role in cancer prevention. In conclusion, vitamin E offers compelling biological support for reducing cancer risk by defending cells against oxidative and inflammatory stress, preserving DNA integrity, and supporting immune vigilance. While the evidence does not currently support high-dose supplementation as a reliable or safe cancer prevention strategy, consistent intake of vitamin E from natural food sources remains a positive and health-affirming choice. In the broader context of a balanced diet and healthy lifestyle, vitamin E continues to be a valuable ally, quietly working to maintain cellular health and reduce the cumulative risks associated with environmental and internal stressors.